And it is asking you to find the no load test, terminal current, and input power. So let's do that first. So it's asking about so first one is the no load test. So what do you mean by no load? So it says no load test. So what do you, in an induction motor, what is no load? Like literally, if you try to understand this word, it's like you don't have a load in the induction motor, and the induction motor is running at a free will, like free rotation of the induction motor. So what should be the sleep when there is a free rotation of an induction motor? Zero. But that's the catch. So in induction motor, it can't be zero. It will never be zero. It will always have some inertia. So it will always be less than zero, but it will be very close to zero. So free rotation means the maximum speed, and it should be very close to zero. It will not be exactly equal to zero. So because if you remember the demo in the YouTube, so you can find that when the speed of the rotor is equal to the speed of the starter, then there is a lock. That means it will run as a synchronous machine. It will not be an induction machine anymore. So so what is the equivalent circuit for a no load test? So because we consider sleep is very small, so we can ignore. Okay, so this is the total equivalent circuit of induction motor. So when the sleep is very low, so we can consider this resistance is very high. So we can consider this part as open circuit. So when you consider this as open circuit, then we just have current flowing through this and this. So our equivalent circuit will be so this is the final equivalent circuit for a no load test. But we don't know the sleep at which this thing is running, right? We don't know. So what is given in the question? So in the question, all the parameters are given. Everything which is here is given. And it says that P frictional loss is given. 150 watts. This is 150 watts. So because it's a no load test, so we don't have anything on the rotor side. So we can consider the mechanical power as a frictional power. Because there is no load at the output. So we can just consider the output power as frictional power. So we can just write E mechanical equals E frictional. Or we can write this one is also equals to it says at rated speed the motor friction and windage loss. So it has both the loss included is 150 watt. So we can consider frictional loss, which is also equals to I square R. Or we can say the rotor copper loss. Now, so how do you find this loss? What is the value of this? So what is mechanical power? We can write the mechanical power as 3IR square or I2 square R2 into 1 minus S over S, right? So you remember this formula? So what is P mechanical? Like if you go for an induction machine, what is P mechanical? You see this figure? This is actually for a different question, but you can understand the P mechanical on this side. So P mechanical is equals to P air gap minus P rotor. So air gap power is, what is air gap power? So what is P mechanical? Is equals to P gap minus P rotor. So what is P air gap? It's just P I2 square R2 over S. And minus what is P rotor? P rotor is because of just the rotor resistance, which is R2. So it will be just 3I2 square R2. So if you simplify this, it will be 3I2 square R2 into 1 minus S over S. Is this clear? Then how we get this formula? This is for the P mechanical. And so this is equals to, what is P frictional? It's 150 watt. Right? So when you see this equation, so which part is unknown? What you don't know in this equation? Sleep, we don't know. We have to find sleep. We also don't know I2. So we have to find I2 also. So if you see this figure, yeah. So if you see this figure, what is I2? You can use current division rule, right? Anyone has question on current division rule? How do you divide a current when you have two resistance? So it's simple. Like if you have a current input, so you know that current is divided into two parts. So if you want to find the current at this inductance, like through this, which is, if I write this as I2. So if you want to find the current at this point, like through this inductor. So you take this current, multiply with the other impedance. So multiply this I1 with this impedance and over the sum of the both the impedance. Like, for example, if I want to just take an example. So this is R2, this is R1, and we have to find this current, which is I2. This is I1. So what is I2? I2 should be I1 times R2 over R1 plus R2. So this is called current division rule. How do you divide a current across this? So this current times R2 over R1 plus R2. So using that you can find I2 here from this circuit. So if I consider this part is ZC, if I say this part is ZC, then we can find I2 from there. And how do you find? Okay, with me. So after that, so you have I2 and S as you have I2 and S as variables, right? So let me go back to the MATLAB and see. Is it visible to everyone? Is it visible to everyone now? Okay, you can see here. So first step is, so let me go down. Okay. So we have to find Pmax. So from the equation we found 3I square R2 into 1 minus S over S. So that's the equation for the mechanical power. And from here we have to find I2. So I wrote I2 equals I1 and I used the voltage division. So I wrote that as ZC. So I1 times ZC over ZC plus the sum of the impedance on the output. R1 plus JX2, R2 plus JX2. And then this I1 you can find it from the input. So you have V input and you can find the total Z input from the circuit, right? So from here you can say this whole thing is V input. So once you have that, so you have all the values. So in the MATLAB you can add everything here and you can just write the formulas. And then I use solve to solve it. So how do solve work? So you write solve and you write the equation. So the equation is Pmax. I stored the equation in Pmax. And we know the value of Pmax is 150 degree. So Pmax equals Pmax minus 150. Because everything you should equate to 0. So by that you have to do Pmax minus 150. So now if I run this thing, you'll find the slip, which is okay. So if you see, you have two values of slip. One is 0.0001, one is 0.9941. So which one do you think we should select in this question? This one?
No, the first one.
The upper one.
Yes.
Why?
This side is
Because it's small, yeah. Exactly. So you find, so now you found the slip here. So this is,
What did you say the reason was?
because we are doing the no load test, so slips will be very small. So this is the smaller one. Any question now, till now? Okay, and I forgot to tell another thing. So when you use solve, so you have one variable which is S, right? So in the MATLAB, if you don't define a variable, you won't be able to solve it. So I am defining the variable as this term, which is called sim, which means symbol. So I defined a variable symbol as s, which means slip, and then I can use the solve to solve it. So if you don't define it, you won't be able to run it. It will show error. Like if I just comment this thing, if I run it, it will say in undefined variable s. So you have to define the variable as sims. Then only you will be able to run it. So let's go back. Okay. So where are we? So now we found sleep. We found sleep. Which is equal to 0.01%.
Nó nữa mà làm mất cầu quên rồi đó.
So what is the
Cũng mất
question?
hết rồi đó.
So the question is asking you to find the terminal current and input power. So just go look at this equivalent circuit. So it's asking you to find terminal
Yeah.
current. What is the terminal current in this case?
Có những môn nổi.
Terminal current is I1. So you know V1 is given the question, so you have to find I1. Can you find it? So this part, everything is known. The equivalent Z is R1 plus JX1 plus this impedance. And then you have to find I1. So I1 is just V1 over the whole impedance you find. And then the next question is asking you to find the input power. So what is the input power in this? How do you find it? It's simple, like, so you have two formulas. One is power equals VI cos phi, 3 VI cos phi, right? Like 3 into V into I into power factor. Or the other one you can use is you can write S, which is apparent power, is equals to V times I conjugate. So VI conjugate, so you found I from the previous step. So you found I, and you can use VI conjugate to solve it. So you know how to solve this in calculators. So you can easily solve this, and after that you just take real value of this. So P equals real of this. That's it. So that's bit A. Any questions till now? Is this clear? What's the next question? Okay, next question says find for the block rotor test conducted at a frequency of 12.5 Hz and a rated terminal current. Calculate the block rotor line to line voltage and input current. So what do you mean by block rotor? It means the rotor is blocked. So that means the speed is 0. So if speed is 0, then slip is 1. Because it's omega m minus omega e, right? So omega is 0, and sorry, omega s minus omega m. So 1 minus omega m. So omega m is 0, so it's 1. Is this clear? So you have so for B, so it's block rotor, which means slip equals 1. So if slip equals 1, what will be the change in the equivalent circuit? So this part is 1. So this will be just R2. It's not changing anymore. So if I draw the equivalent circuit, it will be just V1. So this will be the equivalent circuit. And in the question is asking to calculate the block rotor line to line voltage and the input power. So when the rotor is blocked, so and there is another thing. So in the question it says, so this system is running at a frequency of 12.5 hertz. So the previous one was running at 50 hertz. Yeah, 50 hertz. If you see, the previous one is running at 50 hertz. So this is running at 12.5 hertz. So if it's running at 12.5 hertz, then you have to redefine the value of x1, x2, and x3. Because the value of the inductance depends on the frequency. So everything should be reduced by 25%. So if it is x1, so suppose at 50 hertz, I define x1 as 1 per unit. Then at 25 hertz, sorry, 12.5 hertz, x1 should be how much? 1 times 12.5 over 50, which is equal to 1 over 4. So because there is a change in frequency, you have to change the x1. So don't forget that. And then it's asked, so once you find all the impedances, then it's asking you to find I1 and V1 for the block rotor test. So you know all the values. You know R1, X1, and the ZC, X2 and R2. So you can easily find the I1 and the V1 for that. Is there any question till now? So no question in B, right? So let's go to the last one, which C, which is using the approximation of 6.6, calculate the motor equivalent circuit parameters based on the no load test and block rotor test, and compare the result. Okay, compare the result. So it's actually asking you to use the values from no load test and block rotor test and find the equivalent parameters. So in the last question, so how do you find so if I ask you to find from no load test, what is the parameters you can find? If I ask you to find. So from no load test, you can easily find RC. Because you don't have this side, right? So all the current from I1 is going through this. So if you find the P core, like the core power of the machine at no load test, then you can easily find RC by just dividing the current. Because you can say, what is P core? What is core power? Is equals to 3I1 square RC. So if you have the core power, like core loss, then you can easily find the RC from here because you have I1 from no load test. So what is RC? How do you find RC? So you have P input. So if you subtract this I square R loss, then you'll find power here, right? So yeah, I have, don't look at this, just start from here. So you have P input. So if I subtract the starter loss, starter copper loss, then I will have the air gap power. So in no load test, we don't have air gap power because this part is open circuit. So we can consider P input minus starter will give you the core loss, which is the center. Did everyone take a note of this figure? Because this is really important for the exam too. Like if you have something like if your input power is given and someone is asking you to find the shaft, so you have to actually go through this sequence to find it.
It's gonna be on campus, right?
It will be on canvas.
It's the copper loss from this.
This is copper loss from the starter, and this is the rotor.
Core loss.
Core loss, there is no RC here, so in this case I don't include the core loss. But if you have RC, then here it will be a core loss in the middle.
That's one.
And you can consider the shaft power and the mechanical power as the same. It's the same thing. Okay, let's go to the next one. Okay, so once you find the P code, then from this formula you can easily find the RC. So how do you find the P code? So you can find P core is equals to P input, what is given in the question, minus 3 I1 square R1, which is also, you can find it from here. So this is the starter copper loss, which is I1 square R1, and then you have minus, so in the question it's given the frictional loss, which is P friction. So once you find this, you'll find the core loss. So once you have the core loss, you can easily find RC and also X1. So once you have RC, so you can also find X1 and Xm. How do you find that? So in this problem, I told you to find S, right, which is VI conjugate, and P equals real part of S. So what is the reactive power? Imaginary of S, right? So how do you find the reactive power from the equation, like from the circuit diagram? If I give you this circuit, how do you find Q? It's nothing but how the reactive power is generated. It just depends on the X1 and Xm. So for reactive power, you can just write the formula as, so it's just I square into X1 plus Xm. You can write Q equals I square into X1 plus Xm. So from this, you can find, so sorry, it's I1. So you found the Q from there, so you can easily find X1 plus Xm from here. So that's what the question is asking. It's asking you to find RC and X1 and Xm. And similarly, when you go for block rotor test, so this part, you can find it from no load test. So when you go to block rotor test, so this is the equivalent circuit for block rotor test. So from block rotor test, you can find I2 because you know I1 and V1. And once you find I2, you can easily find, so when you find the shaft power, you can easily find the R2 and X2 from there. So how do you find X2 or X block rotor? It's just, so you find the Q for the block rotor test, because I think okay, in here, so when you find the V1 and I1 in block rotor, you can easily find the power from there, and from there you can find the Q. So once you have the Q, you can find directly the block rotor impedance using this formula. Similarly, you can find the R as P by P over I. So you can use so this all the formulas I have actually given the question in the book, and it's also explained how to do it. So I just explained how you find the block rotor current and the Q and P. So is there any question till now? So let's go to the first question. So let's go to the first question, because depending on the first question, you have 3 questions left. So it's simple. So any question till now? How many guys are happy that this is the last class?
Yes, that's a good question.
Okay, so why? Okay, so this is the 6.20. What's the question? It says it's a 75 kilowatt 460 volt 3-phase 60 hertz squirrel cage induction motor, and there is something you should know is this part. The rotor I square R loss at maximum torque is 8.5 times the full load torque.
Is this the right question?
Yeah, that's question 2.
That's not true.
So that's 2, 3.
I mean, yeah, it's in here, so.
So it's a 3-phase induction motor operating at a rated voltage and frequency. Okay, it has a starting torque of 115% as maximum torque. So you know the formula for starting torque, right? Is there any question for that? So what is?
Why are you doing
So how do you find torque? It's just 3 I. Okay. E cap equals 3 I2 square R2 over S by omega E, right? So this is air gap power. You divide by the frequency and you'll get the torque directly. So this is the key equation. So how do you find? So it's asking you to find. Okay, so how do you find the maximum torque? So anyone has question on how to find the maximum torque? Because it was taught in the class, so I don't want to go through that again. If you have question on that, I will just go through that. No, maximum torque is when you have. So you remember about impedance matching, right? So you have X equivalent, and this is X2, and this is R2 over S. This is V1. So maximum torque will be when R2 over S is equals to X equivalent plus X2. So this is when you find the maximum torque. And what is I2? So I just made this the equivalent circuit simple. I just removed this and put one as X equivalent, where X equivalent is equals to X equivalent is equals to the total impedance from here to here. So I just add everything together to have X equivalent. So what is total torque? So what is I2 now? If I want to find I2. So this is I2. And this is V equivalent. Yeah. So what is I2? So I2 will be simple. It will be V equivalent over X equivalent plus X2 plus R2 over S. Right? So this will be the I2. So if I want to plug everything inside the torque equation, you can find torque equals 3 V equivalent square over R2 square plus X equivalent plus X2 whole square times R2 over S. Do you have any question in this equation? How do you get this? So I just took the magnitude of the denominator. So the magnitude will be this X equivalent plus X2 square plus R2 over X square whole square root, right? If I want to find the magnitude, like if I have like A plus AB, magnitude of this is equals to A square plus B square square root. So using that, I found here R2 square plus X equivalent plus X2 square. Because this is, you can see this is I square. So the square root goes out. So now for maximum torque, so what is the condition for maximum torque? I go here. So the condition is R2 by S is X equivalent plus X2. So instead of R2 over S, here and here I can substitute X equivalent plus X2. So D max is equals to 3 over, it will be just X equivalent plus X2 2 times. I just skipped the step. So if you actually solve it, you'll find the value as this one. Then the question says, okay, the question says the starting torque is 115% and the maximum torque is 230%. So what is starting torque? If you see, just look at this equation. So what is the slip at the starting? Slip should be 1 because speed is 0. Induction motor is starting, so speed is 0. So slip should be 1. That means you just substitute S as 1 and you find the starting torque as, so square over R2 plus X equivalent plus X2 square into R2. Because S is 1. Now to solve this example, you can just like divide both of them, because this is 200 and 115 and this is 230. So once you divide it, you can easily solve this and find the slip. So when you substitute this, you will find that the equation will be in the form of X equivalent and X2. So you can again substitute x equivalent plus x was r over s. So you can easily find it. I will post the solution in the canvas, not the solution, but the explanation.
What the solution if you want.
Every second.
Can I use my email? On your email.
So yeah, it's not that difficult, but a few questions like question number 30 is more difficult. And so you guys know about efficiency, right? What is efficiency and how to find it? It's just if you have an induction motor and you have a shaft power and you have an input power, so efficiency should always be output power over input power. So if it's a motor, then so what's the output for a motor? What is the result of a motor? If I am giving a voltage input to a motor, what's the resultant we are expecting? That's the output. The resultant is the motor is rotating. So how much power is the motor is giving when it's rotating? And the input power is when you are giving the input as voltage. So VI conjugate will be the input power. So to find the efficiency, you can just divide the shaft power over the input. Is it clear? So efficiency is always equals to P out over P in. So for water, efficiency is equal to P shaft over P in. And for generator, efficiency is always equals to P out, like electrical power output, over P shaft. Because in generator, shaft is the input, and the output is the. In generator, we are expecting the voltage as the output, right? So that will give you the P out, and P shaft is the input because we have a like another machine rotating the induction machine. So this is for question I think 23. So that is one important thing for that question. Everything else is easier. So also like induction machine is also termed as a frequency converter because you can see the rotor frequency changes, right? Like when we were discussing about the example in the PSCAD, so we have a 60 Hz input, but with depending on sleep we have a different frequency, which is like 12 Hz, 6 Hz, 6 Hz or something like that. But we also have power electronic converters. So why do we not use the induction machine but we use power electronics converters? Just think about it. So you may get a question on that in the finals. Like why do we use power electronic converters for converting the frequency but not the induction machine? Induction machine can also convert the frequency from a higher frequency to lower frequency depending on the speed, because we know that on the rotor side the frequency is S into Fs, right? You didn't get talking. We can discuss it after that. Let's do the quiz.